Hello and welcome back. We are in Math 1324, Chapter 4, and we are doing the last section for this test. This section is called Matrix Equations and Systems of Linear Equations. Let's go look at matrix equations. Here's a note. It says if a system of linear equations is dependent, or if it has either fewer or more variables than equations, you must use Gauss-Jordan elimination to solve the system. In other words, if there are infinitely many solutions or no solution, then you have to use Gauss-Jordan elimination. But if there's one unique solution, we're going to use a new method to solve the system of equations. The identity matrix and the inverse matrix discussed in the preceding sections can be used to solve simple matrix equations. Solving matrix equations is similar to solving real number equations, except that, number one, there is no operation of division for matrices. You cannot divide matrices. You can only multiply matrices. And we have to keep in mind that matrix multiplication is not commutative. So AB does not equal BA. Remember that with matrices. Okay, so let's go look at the ways we solve the numerical equation 2x equals 10. If we wanted to solve 2x equals 10, first thing we would do is divide both sides by 2. And then we would see that 2 over 2 is 1, so we would be left with x equals 10 divided by 2 is 5. But if we're solving a matrix equation, ax equals b, we can't divide by a. All we can do is multiply by, we can just multiply. So I'm going to multiply on the left of both sides of the equation. I'm going to multiply by A inverse. So what is A inverse times A? That's the identity matrix. Now the identity matrix times any other matrix is just that matrix. So the identity times x is just x. So now we have solved the matrix equation x equals A inverse times b. Now going back over here to the left, we could do it that way with this equation as well. 2x equals 10. I'm going to think about multiplying both sides by the multiplicative inverse, 1/2. Now, what is 1/2 times 2? It's just 1. So I get 1x equals 1/2 times 10. 1 times x is just x. So x equals 1/2 times 10. And we can do that arithmetic. 1/2 times 10 is 5. So we can think of solving a matrix equation just like we do a numerical equation, but we usually don't think this way, like this. We usually think that we just divide both sides by 2. All right, summary. The solution of the matrix equation AX equals B is X equals A inverse times B. That's the solution of a matrix equation. All right, let's go look at some properties of matrices. You're assuming that all products and sums are defined for the indicated matrices A, B, C, and I, and zero matrix. Then the following properties will hold. Okay, for addition, matrices have the associative property. In other words, in parentheses, A plus B plus C is the same as doing A plus parentheses B plus C. Commutative property holds. A plus B is equal to B plus A. the additive identity property. A plus the zero matrix is equal to the zero matrix plus A, which is equal to just the matrix A. And the additive inverse property. A plus negative A is equal to negative A plus A, which is equal to the zero matrix. Okay, multiplication properties. Multiplication is associative. A times B times C is equal to A times B times C. Multiplication has a multiplicative identity. A times the identity matrix is equal to the identity matrix times A, which is equal to A. And the multiplicative inverse. If A is a square matrix and A inverse exists, then A inverse is equal to A inverse A, which is equal to the identity matrix. Notice that multiplication is not commutative. You might want to make yourself a note. AB does not always equal BA. The commutative property does not hold for multiplication. Okay, combined properties. You have the left distributive property of matrices. A times the quantity B plus C is equal to AB plus AC. You have the right distributive property. B plus C quantity times A is equal to BA plus CA. And one more set of properties for equality. The addition property of equality, if A equals B, then A plus C is equal to B plus C. Left multiplication, if A equals B, then CA equals CB. And right multiplication property, if A equals B, then AC is equal to BC. Remember that when you multiply matrices, it matters what side you multiply on. You have to multiply on the same side on both sides of the equation. All right, let's go work with some matrix equations. Matrix equations and systems of linear equations. Use matrix inverse methods to solve the system. Okay, I'm going to write three matrices. First, I'm going to get my coefficient matrix. 3, negative 1, 1. Negative 1, 1, 0, and 1, 0, 1. I'm going to do a little mental check here. 3, negative 1, 1, negative 1, 1, 0, 1, 0, 1. Yes. Now I'm going to put my coefficient, or my variable matrix, x, y, z. Now I've got my constant matrix to the right of the equal sign, 1, 3, 2. Okay, I'm going to go put this in as matrix A, and I'm going to go put this in as matrix B in my calculator. Then I'm going to go type in A inverse B on my calculator. And let's see what we get. Okay, here we go. Second matrix. This is go edit the matrix. It is a 3 by 3, and my matrix is 3, negative 1, 1, negative 1, 1, 0, 1, 0, 1. Do second quit, second matrix, and go look at it. Make sure that's right. It is. Now I need to do second matrix, edit, down to matrix B. This is a 3 by 1 matrix, and it was 1, 3, 2. I'm going to go look at my matrix B and make sure I typed it in correctly. Okay, My solution to this system is going to be matrix A inverse times matrix B. My answer is x equals 2, y equals 5, z equals 0. So again, my answer would be x equals 2, y equals 5, z equals 0. Let's go do this again. Number 2, I need to write my matrix equation. My coefficient matrix is 1, -1, 1. 0, 2, -1. 2, 3, 0. My variable matrix is x, y, z, and my constant matrix is 3, 1, 4. Okay, I'm going to go put this in as matrix A, and this in as matrix B, and then to solve the system for x, y, and z, I would need to type in A inverse times B and see what that is. All right, here we go. Clear. I need to go to matrix and edit. Edit matrix A. It's a 3 by 3. The matrix is 1, -1, 1, 0, 2, -1, 2, 3, 0. Now go look at it and make sure that's correct. Matrix A, that is correct. Now I need to go edit matrix A, or sorry, edit matrix B. Go down 1. It's a 3 by 1, 3, 1, 4. Second quit, go look at it. Second matrix down to B, hit enter twice. Okay. So I want to do matrix A inverse. Let's go see if matrix A has an inverse first. Does it? Yes, it does. Yay. All right, I want to do matrix A inverse times matrix B. My answer is 8, -4, -9. So I would write x is 8, y is -4, and z is -9. One last example. Now we have 4 equations and 4 unknowns. My coefficient matrix is going to be a 4 by 4, 3, 3, 6, 5, 4, 5, 8, 2, 3, 6, 7, 4, and 4, 1, 6, 3. I haven't said anything, but you need to make sure you've got it all in the same order, W, X, Y, Z. If you look up here, notice on like the second equation, there's no X, so I had to put a 0 in there. On this third equation, there's no Z, I had to put a 0, so make sure you've got placeholders for every variable on every equation. Okay, back to this one. My variable equation is going to be W, X, Y, Z. And then to the right of the equal sign, I have 10, 15, 30, 25. Okay, I want to go type in this 4 by 4 is matrix A, and this 4 by 1 is matrix B. All right, second matrix, edit. edit matrix A. It is a 4 by 4. And the rows are 3, 3, 6, 5, 4, 5, 8, 2, 3, 6, 7, 4, 4, 1, 6, 3. Okay, I'm going to go look and make sure I typed it in correctly. Okay, now I want to go enter matrix B, second matrix edit. Go down to B, hit enter. It's a 4 by 1, and the numbers are 10, 15, 30, 25. 10, 15, 30, 25. Go look and make sure it's correct. 10, 15, 30, that is. Okay, now I want to go type in matrix A inverse times matrix B. Hit enter. All right, 81.8. So WXYZ will equal 81.8, 27.8, negative 57.8, and 5.6. There's the solution to that system. Okay, let's go look at one example. Nope. An investment advisor has two types of investments available for clients. A conservative investment A that pays 5% per year, and a higher risk investment B that pays 10% per year. Clients may divide their investments between the two to achieve any total return desired between 5 and 10%. However, the higher the desired return, the higher the risk. How should each client, Bob, Sally, and Jane, invest to achieve the indicated return? Okay, so here's our little table. Bob has a total of $20,000 to invest and wants an annual return of 6% or $1,200. Sally has $50,000 to invest and wants a desired return of 7.5%. And Jane has $10,000 to invest and wants a desired return of 9%. Okay, we're going to let K1 and K2, K1 is going to be the total amount invested, and K2 is going to be the desired annual return. Okay, these are known values, so they are not variables, but they're going to differ for each client. Each client has a different amount to invest, and each client has a different annual return that's desired. Those are your K1 and K2. Okay, our variables are going to be the amount invested in A and the amount invested in B by a given client. Remember that A is going to give back, what they say, 5%, and B is going to give back 10%. Those are your variables. So your total amount invested, X1 plus X2, is going to be K1. Your X1 is going to get 5% return. Your X2 is going to get 10% return, and your total return is K2. So let's go write our equation, our matrix equation. And I gave you a spot down here. All right. Our coefficients are going to be 1, 1, 0.05, 0.1. 1, 1, 0.05, and 0.1. You can ignore these. That's just spacing that I have to put in. Okay, that's our matrix equation. Now we want to solve for the inverse matrix here. You're going to go put that in for A and solve for A inverse. Okay, what is A inverse? Remember how to find A inverse quickly with a 2x2? If not, you can go do it on the calculator. Let's do it that way. All right. A is a 2x2 matrix. So second matrix edit A is 2x2, and it is 11.05.1. Second quit. Second matrix, look at it. That is correct. We want to do second matrix A inverse. Okay, our A inverse is 2, negative 20, negative 120. 2, negative 20, negative 120. That's A inverse. Okay, now we need to solve by putting what desired K1 and K2 in. Okay, so for Bob, K1 is 20,000, K2 is 1,200. So here we go for Bob. Our solution would be x1, x2 equals, okay, we want A inverse B, right? So what was our A inverse? It was 2, negative 20, negative 120. And our B for Bob is 20,000 and 1,200. That was our B for Bob, right? Here's our B. Okay, let's go type that in and see what we get. Here we go. Second matrix edit B, whoops. Second matrix edit down to B. It's a 2x1, and it's 20,000 and then 1,200. Does that look right? Yes. All right. For Bob, we want A inverse times B. So Bob should invest 16,000 in A and 4,000 in B. All right. Let's go do the same thing for, who was it? Sally. She has 50,000 to invest, and she wants a return of 37.50. So Sally, you're going to solve x1, x2 equals 2, negative 20, negative 120, which was our A inverse. And our B is 50,000 and then 37.50. So how much does she invest in A and how much does she invest in B? All we need to go do is edit matrix B and put in 50,000 and 37.50. Now I've already got A inverse B up there, so I'm just going to hit second enter and then enter. So she needs to put 25,000 in each of the investments. 25,000 in investment A, 25,000 in investment B. And let's go do one more. Who was he? Who was the next person? Jane. So for Jane, we're going to solve the equation, matrix equation, x1, x2 equals 2, negative 20, negative 120 times, what did she have? 10,000 to invest, and she wants 900 back. So 10,000 to invest and 900 back. Let's see what we get for Jane. Second matrix edit, matrix B. It's a 2x1. I have 10,000 to invest, and I want 900 in return. second quit. I just need to do second enter and enter. I want to do 2,000 in investment A and 8,000 in investment B. Okay, that is it for this section. That is it for this chapter. And that is it for the information on exam 1. Now let's go practice for this section, and then let's go do the review. Until next time, take care.